Hello students, here is a continuation of 7.5, which really should be more like 14.3, real-world comparisons of exponential equations and functions, actually. So here's number 2, and I went ahead and completed the table, putting in these here for x. This is if y equals this, what's the y value? So if we put 0, 0 times a half plus 3 is this. 2, and I think I already went through most of that in the other video. Now if 2, like 2 raised to the power of 2 is 4, and so forth. And then we have this graph here. And it says give the interval when the linear equation is greater than the exponential equation. So it'll actually be greater when the linear equation, see how it's greater than the exponential when it's between -6, and I'm not going to include that. And then and it goes all the way till when x is +2, it looks like. So between that interval, the linear equation is greater than the exponential equation. And I didn't write that, but it's the one underneath the table. So that answer goes underneath the table. And then underneath the graph itself, it says give the intervals when the exponential equation is greater than the linear equation. So it's going to be greater from -6 on to eternity, because the linear one will keep going down to -infinity, and this one will keep going straight and never hit 0, but will get closer and closer to 0. So I can say from -infinity to -6, that's when the exponential function is greater. And I don't know if we necessarily need union there. It's now also when it's right here 2 and greater. See how this green is higher than the black? Then it will be a union with 2 and going greater to infinity there. And again, you could put that right there. Okay? So that's how you do number 2. And again, comparing these and knowing the intervals is important information. Okay? And again, this is page 204 for non-honors, page 216 for honors. Okay? Next situation, we're going on to the next page. And we're going to do situation A. And we're going to compare this. For number 4, it represents the balance of a loan. Which loan is being paid at a higher percentage or has a higher interest rate? Okay, so if I look at number 4 here, we have, and this balance is in thousands of dollars. So year 0, you take $150,000 loan out. Year 1, you have $135,000 left. So how do you find the interest rate on that? Well, what you do is you take the second year. So this can be considered our x values, and this is our y values. And what I want you to do is take y2, so this is y2, and divide it by y1. So if I take 135 and I divide it by 150, if I have my handy dandy calculator, and again, it's the second y that you use. Okay, that equals 0.9. Okay, so we're actually going to be owing less, so the numbers are going down, and it's going to be a decay. And I think I will do the rest of this in red marker. Okay, so it's a decay. Our factor is 0.9. Okay, so our rate is being paid. We take 1 minus 0.9. and we get 0.1. So our rate is 0.1, change it back to a percent, our rate is 10%. Remember, we can change this, move it over twice. 90% plus 10% needs to equal 100% when it's a decay problem. If it was a growth problem, it would add up to higher than 100%, okay? So this is being paid at 10% rate, and the factor is 0.9. Now we look at situation B, where we have at time 0, $300,000 loan. After 1 year, they owe 240,000. So let's see what rate that is. If we put this is Y2, and I'm going to divide it by Y1. And again, it has to be just 1 year increments when you use this formula. So I take 240 and I divide it by 300. Okay, and if I do that on the calculator, I get 0.8. So the growth, is it growth or decay? Well, it's going down here, so it's got to be decay. And the factor, 0.8. Okay, so I can convert that to percent and make sure it's 80. And then I subtract that from 100, so I get the interest is at 20% right there. So which loan is being paid at a higher percentage or has a higher interest rate? I would say situation B. Okay, and we're all done with number 4. Okay, I'll do one more because I know these story problems can be challenging. Let's jump to number 7. And this is going to be investments. So that means you're putting money in the bank and you want to earn money on it. So situation A, initial investment of $25,000, you earn interest at a rate of 5%. Is it a growth or a decay? Well, if you're earning money, it's a growth. So your factor, again, is going to be, you're going to add 100 to this. So it's 105%. But if it's a factor, it's 1.05. You move the decimal over twice. And the rate is 5%. It's straight across right there. So it's pretty easy to read that. Situation B is a little more challenging because it's a graph, but I wrote the information at 0 time, it's $5,000. In 1 year, it's $6,000. So this will be my Y2, and this is my Y1. So I take my Y2, 6,000, and divide it by my Y1, 5,000, equals 1.2. And that will be my growth factor, 1.2. Now, to get the rate, I move the decimal 2 places over, so it's 120%, and then I subtract 100% so that the rate is 20%. Okay, so I think there's one more question on here. Which loan, oh, nope, not that one. Which investment is being paid at a higher interest rate? So higher interest rate, that would be situation B. And I didn't write the problem down, the question. It's already written there on your thing, but situation B has a higher interest rate of 20%. Okay, I think you can get the rest of this, students. You rock.